This is a video on Chapter 5, Algebra for Year 8 Maths. But just quickly, before you go ahead and try and to do any of this stuff in this video, you may have to make sure that you have fully revised for this topic, because as you can see here, this is a challenging test. And on your actual test, there will be a number of questions on here that will not be as hard, anywhere near as hard in your real test as this challenging test. So, but as you can see, things such as finding coefficients and substituting and using your index laws, a lot of the questions in here will be on your test, of course, but they might be a little bit easier. But that's fair to say that if you can do the stuff on this test, you should have nailed all the skills for your actual test. So I'm going to go through these as fast as I can. The coefficient of A for question 1. Well, the coefficient of A, the only term which has just A in it is this one here, and the coefficient of that is 7, the number out the front, which is 7. So that's a nice easy one to get off started with. Now it says here these worded ones, 1/10 of the sum of x and 9. Whenever you see something like the sum of x and 9, I'd like you to use brackets, please. So the sum of x and 9, we have that, and we want 1/10 of that. So that is the same as dividing through by 10, or if you like, we can have 1/10 as a fraction out the front of x plus 9. Now, if you go to expand those terms like so, that will give me x over 10 plus 9 over 10, and the only answer there is C. This one here involves substitution, of which if I've got, so wherever x is, I'm going to replace that with -3, and please use brackets again. Once again, this is going to be tricky. We've got minus and then x squared, and then x is -3 squared. Okay, and this is a lot of negatives in this one. -4 times y, which is 4. So first of all, use brackets. Now, if I had a -3 and I multiplied it by itself 3 times, that's what this cubed is. First of all, we're going to have a negative, and times a negative is a positive, times a negative again, the result is going to be negative. Now 3 times 3, or 3 cubed, is 27, but it's -27. This one's a bit of a tricky one. I wouldn't expect you to get too many like this in your test, but it's a good exercise nonetheless. Now -3 squared is -3 times -3, which is +9, but don't forget you've got this negative out the front, which we have to carry over. -4 times 4 is -16. So now what I have is I have -27, -9, -16. If you think about it, if we add 27 and 16, that's 43. We add 9 is 52. But of course, we're looking at the number line and we're in the negatives, and when I subtract a positive number, we're going in that direction. So it's the answer is negative. The answer is -52. Highest common factor. Well, first of all, the highest common factor we're looking for. What is the lowest, the highest common factor of 32 and 24? Now that might help us rule out a few of these. First of all, is 4 go into 32 and 24? It does, but it's not the highest common factor, so we could get rid of that. The same thing, we've got an 8 over here, but in actual fact, these things share A's and B's and C's, so 8 is definitely not the case. And over here, you've got like a 4, given the fact that the highest common factor of 32 and 24, we've got 1 times 32, but in actual fact, you know, what you've got is you've got 4 times 8 is 32, and the highest number which goes into into 32 and 24 is 8. So that's the highest common factor. So in actual fact, without even doing it, we have ruled it down to these two guys. Now, what do they have in common? Let's just rub this out a bit so we can see. So you can see there that they both have an A, and the highest thing is A to the power of 1. They both have a B, but it's squared. So you can see there that B squared is a common factor. And also they have a C as well. So we've got a C to the power of 1 here and a C to the power of 2. So as you can see, the highest common factor of this is 8A, B squared, and C. That's what they have in common. I think you might need to work on these too. But that is a much trickier one. You probably won't have one that hard. All right, an expression for the area of this rectangle. Now, what I guess you should really do when it comes to these things is if we wanted this area here, what we can say is, well, let's look at the length of this rectangle. Area is equal to length times width. Now, I'm going to call this length in terms of algebra, a plus 1, and I'm going to use a bracket. And as you can see, if I have a 4 and b, this distance here is 4 plus b. Now, I can actually do something like that. Now, when you expand brackets, we've got to use distributive law, and there's actually going to be this term times this term times this term, and so on. And if I was to expand those out, a times 4 is 4a, and a times b is ab, 1 times 4 is 4, or 1 times b is b. Now, if I add those together, which one of these is going to be the answer? It's certainly not this one for b. We don't have ab plus 5. That doesn't make sense. In actual fact, what they've done is they've actually just, this answer here, I didn't notice this, this answer here is actually over here. Okay, so there you go. But of course, I expanded it out over here. Which of the following expressions is the same as this? Well, when you have your index laws, first of all, let's put a little 1 there. What do we do when they're in the brackets? We multiply the powers. So what we're going to do is we're going to do each one of those terms. 1 times 3 is 3. 2 times 3 is 6, so that's a to the power of 6. And there's a little 1 there as well for b, so that's b to the power of 3. Now, of course, we simplify this 3 cubed as 27, a to the power of 6, b to the power of 3. So that answer is E. Now, some of these ones, once again, this is going to demonstrate quite a few skills. First of all, you need to factorise the numerator, and we need to factorise the denominator, and you'll probably find that we'll be able to simplify it a fair bit. Now, let's have a look at 12x and 8y for starters. What do they have in common? Well, for starters, they have a 4 in common, don't they? 4 goes into 12 3 times, 4 goes into 8. But the question is, do they share an x and a y? No, they don't. Okay, so these are two separate. So the highest common factor is 4. 4 times what gives me 12x is 3x, and 4 times 2y gives me 8y. And now over here, we now want to find what do they have in common. They don't have an x or a y in common, but what they do have in common is that 7 goes in there. Now I'm going to do it the other way around. 7 times what gives me 21x, that's 3x, and 7 times 2y gives me 14y. Look at that. Isn't that nice? Because now I've factorised that. 3x plus 2y, then cancel, and the answer is 4 over 7. A lot of these questions you would not have this many tough ones on a test, so I will remind you, this is the challenging test. Challenging test. So just remember that it's the same skills apply, that they're just a little bit harder. All right, now this one here, we're looking at simplifying the following. Whenever you have these things, I want you to get the numbers, and we're multiplying these things. So the numbers just come out the front. 4 times 5 is 20. And now what we're doing is we're using our index laws for the x's. And whenever we're multiplying indices of the same base, so x squared times x, or x to the power of 1, what we're doing is we're adding the powers. 2 plus 1 is 3. Okay, that's a lot different to when they're in the brackets, like we were doing before. And then we've got a y there, it's just by itself, hasn't gone anywhere, done. Over here, we've got a 9x times 8x times 2x. So 9 times 8 is 72. You would have easier numbers than this, because then 72 times 2 is 144. So let's get that number 144 out the front. Now there's a 1 here, a 1 here, and a 2 there. So when I've got indices of the same base, x, x, and x all multiplied by each other, we are adding the powers. So that is x to the power of 2 plus 1, which is x to the power of 4. Okay, we're going to proceed and go over here. Now, when you have indices of, I'm going to break this up. If I break this up into three different things, we've got a squared, we've got a b over here, and then we've got a 30 over 12. In maths, you can break things down to make your life a lot easier if you wish. Some students will be able to do it in less steps, but let's sort of break this down. If I just had, in year 7 fractions, if I had 30 over 12, I need to simplify that. Simplify means we're taking out your highest common factor, we're dividing through by the highest common factor. So let's deal with that first. If I have a 30 and a 12, you'll notice that 12 doesn't go into 30, but 6 does. So if I was to divide that by 6 and I was to divide the bottom by 6, then what I'm going to get is that goes in 5 times and 2. So that is going to be equal to, when I divide that by 6, that's 5 over 2. So that is your simplified fraction for 30 over 12. So go ahead and do that. We're going to just sort of do that here. I'm going to replace that with a 5 on the top and a 2 on the bottom, and they're going to stay there. But now let's look at this one, a squared over a. Now what we're doing is when I have two indices of the same base and we're dividing, I'm subtracting this power of the denominator from the numerator, this guy over here. So 2 take 1 is 1, and of course we don't write a to the power of 1, we just write a. And look, the b, there's only one b there, and the b just stays there. So the answer is 5ab divided by 2, and that is simplified. Notice that 5 and 2 are both prime numbers. If one of those is a prime number, then there's no way we can simplify it any further. Okay, we're going to keep going. Now, a few fractions. Remember, when you have fractions in the same numerator, the same denominator, we can add them. So what we can do is, if I was to have minus 7k plus 4k, and I can bring those together because those denominators are like. So what we've got is, now I've got to do, in the integers unit, we would have been adding minus 7 and 4. So minus 7 plus 4 is minus 3. Minus 3k, of course that k didn't go anywhere. And if I have 4 kayaks and I subtract 7 kayaks, I have negative 3 kayaks. And now what we're going to do, though, is we need to simplify. See, there's a number there, 3 and 9. What do they have in common? Well, you can be divided by 3. So I'm going to divide both sides by 3. That's going to give me negative k over 3. And we're done. Now, a little bit trickier over here because we've got 8 and 14. Usually you'd have numbers which are probably a little bit easier to find lowest common denominator, LCD, we can sort of say. Now, LCD, the lowest common denominator for these two things, we've got 8 and 14. Now, let's do the multiples of 8. 8, 16, 24, 32, 40, 48, 56, and if I do 14, 28, 42, 56. Look at that. Okay, same process as exactly before, but or whenever you've done fractions, but maybe we just have to spend a little bit longer finding what this is the lowest common multiple. Okay, so what we're going to do is this needs to become 56. So in order for a 14 to become 56, we need to multiply that by 4. And if I'm multiplying the top by 4 with fractions, you have to do the same to the numerator. And we've got a 5 in over here, and I have to multiply 8 by 7 to get to 56. So I'm going to multiply that by 7 over 8 times 7. So what do we get when we get that? 4 times 3n is 12n over 56, and 5n times 7 is 35n over 56. I have two like denominators, so now I can add the numerators. 35n plus 12n is 47n over 56. Now we could, 47 as it turns out is a prime number, so there is no way that we can simplify this any further. There is no number other than 1 and 47 which are factors of 47. Okay, so look, there's been some challenging questions here, but if you are understanding this process and if you work through these, you're going to find your test really straightforward. Your pre-test will be a good indicator of the sort of the skill level that you'll need. Let's go ahead and expand these brackets out though. We've got minus 4a times 6. So 4 times 6 is 24. The a didn't go anywhere, and a negative times a positive is a negative. So that's negative 24a. And negative times negative is a positive. 4 times 2 is 8. So that's going to be plus 8. And guess what? These a's and b's didn't go anywhere. And now what we've got is at the end, don't forget we have a negative 5a. So now what we're going to do is we're going to collect like terms. The only like terms are these ones. We've got the a's. We've got negative 24 minus 5a is minus 29a. And of course the ab, well, that just stays there. And this is, we've expanded it. We've expanded it first of all. And then we've combined the like terms where possible. Okay, so let's do this over here. That 4x comes down. 2y times 3x. 2 times 3 is 6. And I'm going to call that 6 and 6xy, if you like. We don't write 6 times x times y, 6y. And 2y times minus 5. 2 times 5 is 10. A negative times a positive is a negative. Negative 10. And look, this is a little 1 there, and this is a little 1 there. When I have two indices and I'm multiplying them, I add the powers, so that's y squared. You guys know that y times y is y squared. It's the same as 2 times 2 is 2 squared. It's the same thing. Okay, minus 8x plus 10y squared. Now what I've got to do is got to work out what my like terms are. So just quickly, let me get my highlighter out here. Here's a highlighter, and I'm going to highlight the like terms. Now just quickly, I've got an x here. Okay, and I've also got an x here, just an x. There's no other things like y's and stuff. So those two are like terms there. And you might notice over here we've got an xy. Well, xy is just by itself. There's nothing that we can really do to simplify that. But look at this. We've got a minus 10y squared and a positive 10y squared. If I have 10y squared and I subtract 10 of them, I'm going to have 0 of them. So my answer is they're going to cancel out. 4x take 8x is negative 4x, and I've got 6xy. So my answer is 6xy minus 4x. And we have now expanded and collected like terms and simplified. All right, I'll just take a little breath there. We don't have too much more to go, and I'm trying to get through this as quickly as I can. Now, just quickly, 12w minus 18w squared. We need to find the highest common factor, and in order to do that, that's how we factorize. We want to do the opposite of expanding. We want to have some brackets with the highest common factor at the front. Now, what do they share? Do they share a w? Yes, they do, but only one w. They're only to the power of 1. Do they share an x? No, they don't share an x. So what we're going to do is we're going to bring out the number which is the highest common factor, which is that, what do they share? And they share a 6, don't they? 6 goes into 12 twice and 18 3 times. So what we're going to do is we're going to put that 6 out the front. But don't forget, they share a w. So we're going to have a w out the front. Now you can open up some brackets. 6w times what gives me 12w? It's 2. And be careful, I've got a positive here, I've got a negative over here, so we need a negative, and that is negative 3. W times w gives me w squared, and guess what? We've got this little x here, so that must be x. So as you can see there, we have now factorized that. Okay, over here though, we've got an expression, or 3 expressions, probably a bit trickier than what you would expect, but nonetheless, you can do the same. What do they share, though? They share 7 goes into 14 and 28, and of course 7. So the highest common factor as far as the number is 7. But do they share anything else? Well, before I open that bracket and start diving into that, they all share an x, that shares an x, and that shares an x. So we're going to rub that out, and we're going to put an x there. Now, do they share a y? No, only two of them do, so they don't have that. We certainly can't factorise and bring a y at the front. What times 7x gives me 14xy? Well, that's 2, and then we haven't forgot the y, have we? And what times 7x gives me minus 7x? Well, that's just minus 1. And over here, we've got plus. We know that's going to be 4. And look, x times something is going to give me x squared. That's going to be x. And y squared, well, y squared just is going to be y squared, like so. Now we're factorised. Okay, we're going to simplify a few things using more index laws. So, first of all, whenever you see this, let's put a little 1 there. So what we're going to do is indices. These indices are all of the same base. We're using index law 1, which is when we multiply, we add the powers. 5 plus 2 plus 1 is equal to 8. And, well, there you go. It's now simplified. Once again, though, over here, like I said, whenever you have these things, get the numbers and bring them out the front. 4 times 6. There is no index law for 4 times 6 because these things, if they were indices, they are of a different base. Let's write it even out the front. We've got 4 to the power of 1 and 6 to the power of 1. We can't do anything with those other than the fact we can multiply 4 times 6, which we've been doing since primary school, which is 24. And over here, we've got all of these n's. They're all the same base. Let's write it out. We've got 3 and 1 over here. That's a little 1 there. So that's 3 plus 1 plus 6 plus 50. And of course, we're going to write that into the next line, and that's going to be 56, 7, n to the power of, when you add those up, 60. Now, you might recall, if you've revised, that anything to the power of 0 is equal to 1. Anything in brackets to the power of 0 is also equal 1. However, if I was to equal, put a 4 out here, it does not equal 1 because, of course, this thing equals 1 and 4 times 1 is equal to 4. So be very careful when you're doing these things. Yes, anything to the power of 0 is equals 1, but if I have some constant at the front like this 4, it does not equal 1. So what we're going to do is we're going to get the numbers first. 5 times 7 times 3. Well, 5 times 7 is equal to 35, and 35 times 3, if you were to do it, so 3 times 3 is 9. 90 plus 15 is 105. So let's get that number and put it out the front so you don't have to deal with it anymore. Now, what we're going to do is I'm going to replace over here, though. I'm going to replace over here. That's 1, isn't it? So that's 1. That's equal to 1. This is equal to 1. This C doesn't go anywhere, though. And well, if the C is sort of a bit lonely, it's by itself, it doesn't have anything out there. So there is going to be, I'm going to leave room for my A's, B's, and my C's over here. So I'm just going to put that C there, just for this time being. Now, what's left over? We've got A, and as you can see, this is equal to 1. So 4 plus 2 is 6, A to the power of 6. And there's a little 1 there, isn't there? That helps when you're doing this. 1 plus 8 is 9. So that's B to the power of 9. And that's the answer. Okay, now we're going to keep going. There's a little bit to go. I'm not going to finish all of this potentially, but we'll see how we go. Talking to yourself? I'm making a video. So just quickly, I'm going to divide the highest number which goes into 18 and 45 is 9. So the highest number which goes into 18 and 45 is 9. So what we've got is we're doing dividing both by 9. Now that's going to be 2, and that's going to be 5 on the top. And with this 18 take 11 is 7. So that's your answer there. Same thing over here. Let's do the numbers. 24 divided by 12 is equal to 2. X4 divided by, let's break it up in a few little ones here, like so. And we've got y to the power of 5, y to the power of 4, and then we've got a z on the end. So first of all, what we're going to do is bring that number out the front. Now, let's do this one. X to the power of 4 divided by x cubed. What are we doing to the powers? We're subtracting that 3 from 4, which is x to the power of 1, which we'll just write as x. So there you go, we've got x, and the same thing with y to the power of 5. That's y, and there's the z. So we've now simplified. All right, we're just going to work through going through some with brackets here. When you have brackets, that's the third law. What you've got to do is you've got to multiply the powers. Because I'll show you something. If I had 8a squared, that's a times a. And if I multiplied that by itself 5 times, that's going to be, and this is quite long and drawn out, you shouldn't be doing this, but I'm going to show you that is like so. How many a's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. So that is going to be a to the power of 10, b to the power of 0, c to the power of 5, times a cubed bc. So what I'm doing to the powers is I'm adding the powers, which is a to the power of 13, and b, and we've got over here the c's, which is c to the power of 6. Just going to finish this off before I stop this video. We've got these, we're going to multiply the powers, so we've got n to the power of 6 over here. Now just we've got a little 1 over there, so that's going to be times, we've got 2 to the power of 1 times 4, which is 4, and n to the power of 2 times 4, which is 8. Bring the 2 out the front, like so. Now let's simplify that. In 6, we know that that's 2 times the power of 4 is 16. N to the power of 8 times 2, n to the power of 8. Bring those together, that's going to be 32. And then what am I doing to the powers? 1, 2, 3. I'm going to add those powers, and that is going to be 16, 22. 32 n to the power of 22. All right, I'm going to stop there. That's probably enough on index laws. Just going to finish on this extended response question. Now, in your test that you'll have on Friday, you will have a question sort of similar to this, and it'll be a worded question. I can't necessarily prepare you for it, but you've got to read each question carefully. It says here, Michael would like to build a fence around his paddock. The diagram is not to scale. Now, he wants to build a fence, and that means that you can see there that this distance here, if I add this, because they're sort of at right angles, that would be 4, because this is 4, and this distance here is also y, so that's 4 plus y. And over here, this distance here is, we've got over here, that's 5, and this is x, so this is 5 plus x. So let's do that straight away. Now it says find a simplified version of the perimeter of the paddock. So what I'm going to do is, the perimeter, of course, is the distance around the outside. So we're going to add all these together. Okay, 1, that's y, plus 2, that's x, plus 3, this is this distance 4, okay, and then we've got plus this one here, which is 5, plus 4 plus y, plus 5 plus x. Okay, so now what I'm going to do is I'm going to combine all of those together. So we've got 5 plus 5 is 10, plus 4 plus 4 is 18. So that's 18. Combining those are like terms. So the numbers are like. Then we're combining all the x's. We've got 1x and we've got 1x over here. That's 2x. And then we've got a y over here and a y over here. There's 2 of them, 2y. So this is the simplified version of the perimeter of the paddock. Note what you're doing is you're adding those terms, you're collecting the like terms, you're adding them together and simplifying it. Now it says here, if x is twice the length of y, substitute into the expression to find the perimeter in terms of x only. So what we're doing is x is equal to 2y, okay? Or we can say that if x is equal to 2y, then y is equal to x divided by 2. So let's go ahead and substitute that in over here. Let's replace, wherever I've got y, I'm going to replace it with x divided by 2. Let's try that. So my perimeter is equal to 18 plus 2x. We only want terms involving x. So 2y, well, y is x over 2. So that's like so. Now when I do that, look at that. That's going to cancel out. 2 divided by 2 is 1. 2x plus x is 3x. My answer here is 18 plus 3x. And finally, find a simplified version for its area in terms of x only. Well, as you notice over here, we could do this a number of ways. If I was to do the area, I can basically get the area of this, and I can get the area of this, like so. I could combine them together. So I've basically got two rectangles, okay? So this, first of all, a little bit tricky. We're going to do the area is equal to, I'm going to call this area in here, I'm going to call that area 1, okay? So let's do that. That's going to be the area is equal to, this one takes a little bit more working, plus area 2, where 2 is this rectangle down here. Now let's work this out. Area 1 is equal to, I'm going to just rub this out for now so I can see it. That's a rectangle which is 4 times 5. The length is 4 and the width is 5. And then what we're going to do is we're going to add area 2. Now the area 2, can you see over here, if this is this distance here is y. And this distance over here is 5 plus x. So we're going to have to multiply y, and we're going to have to multiply y by 5 plus x. So let's go ahead and expand this out and simplify now. So 4 times 5 is 20. 5 times y is 5y, and x times y is xy. Now it says here we want for its area in terms of x only. So, but we know that y over here is x over 2. So we've got 20 plus 5y plus x times, now we're replacing y with x over 2. So this one's going to be a little bit different. Oh, actually, sorry, my bad. Okay, so 5 times y is 5x over 2. And x times y is x times x over 2. All right, so now what we're going to do is we're going to bring these two together. That's 20. 5x on 2. Well, we can't really do much with that. 5x on 2 is the answer. It looks a bit ugly because of fractions. X times x is x squared. We're adding the powers. 1, 1. X squared. And 1 times 2 is 2. Now, you can see here we've got an x squared term and x term. There is no things that are like. We've now simplified that. And as you can see, it's in terms of x only. Okay, can you see that there's no y's or anything like that? It's just x's. And we now have a simplified form of our area. Now, when we're getting into problems like this is, I guess, why we're doing algebra. And at the moment, you might sort of feel as though we're just sort of working on the skills, but it's really important. You need to work on these skills, getting them correct before we can really apply them. So you will get the odd question, which is just a worded question, turning algebra words into some basic algebra expressions. So make sure that you do revise over those for your test and have your coursework finished. So I think that that's probably going to wrap things up. But what I do want to say, but before you finish watching this, is that all of these questions in your Year 8 test, this is probably well beyond the skills that will be testing you on. If you had a test like this, it would be really tricky to because there isn't too many easy questions amongst here. But if you were to nail the skills and the stuff that we've done in this video, it will take you some time, then what you will find is that anything that's tested on this year will be much, much easier. Right, so I'm going to stop there. Good luck for your test, and yeah, I hope you all go well.